a little below it. Would you say 10? 65? Kayleen?
8.5 and 65.
65, wow. Mia?
6 and 62.
6 and 62. Logan?
9 and 65.
Stritzel's not here. Swenson?
68. Shoe size is 10.5. Height is 68.
Watson?
8 and 66.
And Madison Woman?
7 and 62.
7 and 62. Okay. Now, here's the deal with scatter plots. Okay, scatter plots are a way for you to try and arrange data so that you can tell if there is some sort of correlation between people's shoe sizes and how tall they are. Is there a relationship between that? In other words, is the bigger their shoe size, the taller they are, or vice versa, maybe it's smaller. And that's what you're doing. You're taking this data, this information, and we are going to try to graph it on this coordinate system here. Okay, and we've got our little x axis is this one right here. Okay, and that would be probably your shoe size, because you take the whatever one doesn't change, the one that you're given, and try to figure it out. Now we have to come up with some way, how do we represent this on our little thing here? What was the range of our data? What was the smallest shoe size we had?
6.
6, and it went all the way to 13, right?
Yeah.
So we could probably, how many squared was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Sure, why not? Let's just call it that. Shoe size 0, which is no such thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We'll label it as shoe size. And then the other axis would be height. And the range of our height goes from what's the smallest? 60 what?
Nothing's under 60.
61 to 7. Nobody was taller than 72. So we could probably do that, one for each line, starting at, I guess, we can start at the bottom being 60. Can we do that?
Yes.
Usually what you do is this, you put a little, because you're not starting at 0 here, put a little squiggly line, that means that line breaks. This is 0. And we're skipping all the lines from 0 to 60, so we'll start at 60, 61, 62, 63, 4, 5, 66, 7, 8, 69, 71, 72. We'll probably stop there. So here we go. This is the exciting part. Very, very exciting. So now we try to plot all this stuff here. So you got 8.5 and 61. So 8 and 61 is right here. So 8.5, 61 is right here. Put a big old fat dot there. Can you work with me here? You should be able to do this on your own. I shouldn't have to guide you too much. 13 is 72, so 13 here. I guess I gotta go way up to 72. 13, 72 right here, right? Oops. I guess I better do that. Somebody should read them off for me because I can't keep going back. But I can make this smaller, can I? 8.5 is 62. 13 is 65. People are killing me. Or 65. Are you doing it on your own or do I have to help you with this? 10 is 65. Oh, 10 is 65 again. Guess we can't put that twice. 8.5, 66. So many people are messing with it. 9.5 is 65. This may or may not work. 12 is 70. 8 is 64. 7.5 is 62. 10 is 65. Is it the second 1065? We have 3 1065s.
That's a third and 65.
Yeah, 8.5, 65. 6 is 62. What in the world? 9 is 65. 10.5 is 68. I like that. Who is that one?
David.
Thanks, David. You kind of made the graph, actually. 8 to 66. Good for you. And 7 is 62. As did 762. Everybody got it? We're getting close. Give you a second on that. With that?
What's your on your paper? Did you write it down when you were talking?
I don't have that kind of time. Okay. And here is the deal. When you have a scatter plot, children, there are 3 things that can happen. One is there can be a positive correlation. I spelled that right. You could have a negative correlation. How do you spell that? I think that's right. Or number 3, you could have no correlation. And the first thing you have to understand is that, you know, this is not a specific science. This is just kind of an observation. If when you look at the graph, it seems like there is a pattern of dots that goes up from left to right, then that is a positive correlation. Okay? Dots go up from left to right. If those dots would do the opposite and actually go down from left to right, with respect to slope, then it's negative correlation. If when you look at the graph, the dots are all over the place and there doesn't seem to be any up or down or anything with it, it is no correlation. You can't see any sort of a pattern to it. And as you can tell with ours, the thing that we did, there definitely is a positive correlation between shoe size and top height. It's just the way things work. Okay. So now, what is the point of this? Well, you can use scatter plots to predict, you know, how tall somebody is going to be based on their shoe size. Now, it probably would help us if we had waited another 3 years when some of you started and stopped growing, because some of you have grown already, some of you haven't. But what you're looking for now is what's called the line of best fit. And what that simply means is this, and here is where things get a little, you know, there's no right necessarily wrong. There's probably better and there's worse. But the deal with the line of best fit is this. You want to try to pick a line, and this, whoever this person is, I don't know who this person is. This person would be called an outlier because that dot is so far outside of where everybody else is. Is that your name? Who's this one? Who's 13? Who's size 13? Who? Okay. Odds are, Cameron, you're probably going to grow and end up here eventually, but right now you're stuck. Did I get that right? You're 65 inches tall? You're only 5'5"? Are you 100% sure? Did you go stand up to that door? I just want to make sure. Are you sure you're only 5'5"? I'm going to go and predict that maybe he's a little taller than 5'5".
Yeah.
Yeah, you're 5'7", my friend. So that dot there should be up here, and it's still a little bit out, but it kind of works a little better. So what you're looking to do is you have to take a ruler and you try to split these dots, kind of imagine a line that would go kind of right through all of them where the same amount, the same number on top would be the same number on bottom. And I suppose if I were doing this, hope my line's not going there. If I were doing this, it would end up being, I don't know, let's take a look at that. Any thoughts on that? Would you go a little, would you move one way or another? What you thinking? Nope, no, we're not doing, this is not a proportional sort of thing. It doesn't have to go through 0. I don't know, would you go above that or below that? That kind of looks pretty good to me, I don't know. Okay, and then with that line, 2 things you can happen. With that line, you can get an equation. You should be able to write an equation. The problem with our equation is we're not going to know where it crosses the y-axis unless we kept the line going there. But with that line, you can predict if anybody had a shoe size of what, how tall they would be. For example, let's say if somebody had a shoe size of 11, does anybody in here have an 11? You could follow that 11 up and see where it crosses that line right there. You're thinking if somebody is an 11, they should be close to, well, like 68.5 inches tall. Or close to 68. Or what if their shoe size was a 6? I guess we can't do 6 because we didn't go down here. If the shoe size is a 7, do we have a 7? Yeah, we already had a 7, so they're there. If they had an exact 8 for a shoe size, I mean, you could predict that they would be right there at 63. Is it 100% accurate? No. It's a prediction, but it will get you awful close. I mean, you look at most of these numbers here, except for still Cameron English, whose shoe size are big. Are your shoes big on you? Are you sure you shouldn't be in like a 12 or something like that?
No, they're actually not big on me.
Okay. Or you could kind of go the other way too and say, well, if somebody's, if somebody's 6 foot tall, they should be that shoe size. Or if they're 5 feet 11, looks like they would be at, 12.5 shoe. Or if they're 69 inches tall, they'd be somewhere around 11.5 shoe. So scatterplots have their place where you can predict and kind of try to figure out some sort of things like that. Doesn't that sound like, we did this last year, right? Because somebody must have had it. What's that? And when we go to La Computadora Laboratory, we will do some stuff on scatterplots. By the way, some of you, I need your rough drafts. How far are we?
Oh, I'm done. I actually have mine.
No, I just need a rough draft. I don't want any more. Don't push me into things I don't want to see.
What is that, Jill?
The official paper is due on the 20th.
How far are we from rough drafts?
I'm done.
When is it due?
The whole thing, the last day we come Thanksgiving, before Thanksgiving, 23rd. Final draft the 23rd.
So when is the rough draft?
This is not,
I've done the first.
I don't want
That'd
to.
be great. I'm not even done with the first page.
9 days.
I'm going to see a copy of your rough draft that has marked notes from whoever your rough draft reader is. So I look at Cameron English, you look at, he's got this, although I don't see the switching stuff around. And I will also get a second copy that is your final draft. Where you can make sure there's no spelling, grammatical, or whatever. It needs to be in MLA format. I know you've done that before.
When is the rough draft due?
When the
May.
Right, the day before the thing. Final drafts, they're all due soon. I'd like to see a rough draft beforehand. You want me to, let me put a mark on it? No later than Wednesday.
Oh.
Rough draft.
This Yeah, Monday next.
But then you don't have time to make your final draft.
Yeah, we do.
I'll make
Alright, Monday next week, okay.
That's serious.
Yeah, that's.
I have.
Look at this, look at the sheet I just gave you. Let's just make sure you got it here. Look at the practice there. Has everybody got one? Did I give you one?
I don't think I got a sheet.
This math one, this thing here. It says describe the relationship indicated on your scatter plot there. What relationship is that? Your choice is positive, negative, or neither. Which one was that? Is that those dots going uphill, down here, or no correlation? Positive, and then it says, on your scatter plot, if you were to sketch the line of best fit, would that go through the origin, yes or no? No, but you gotta look that it does cut out, it does cut certain things out of it, but it looks like it's gonna cross like at 5 or something like that. Find the slope of the line of best fit. Okay, now we didn't talk about that here, but all you have to do is this. Here's my line of best fit, and again, this is not an exact thing, but if I were looking for the slope of my line, remember, you need to make a triangle out of this. In order to make a triangle, you've got to find a place where the line intersects one of the crosshairs of the x and the y axis things. And on mine, certainly I would go right here. I would make this one point of my triangle. And then I need to find another place on this red line where it kind of goes between, where it kind of hits a crosshairs. And it doesn't look like many, but maybe this is kind of a goofy one because that makes an awful big triangle. You know, you can kind of fudge it a little bit and maybe even go right here. Let's say I made that my triangle. What is the slope of that right there? How high is it? 2 over how wide? 1. So a slope of 2. It's not an exact science. If I were to use this one, let's say I use this one, would it come out to be awful close to that? How high is my, I would use this and this is my triangle. How high is my triangle? 1, 2, 3, 4, 5, 6, 7, 8, 9. How wide is it? 5. Is that close to 2? Relatively, a 9/5 slope. You can't be marked wrong when you're like, it's not an exact science. So, is there predictive value to results? Well, what does the slope mean in the solution? Select another pair. Yeah, blah, blah, blah. All right, so there you go. What should our assignment be, you ask? With all of the whining and complaining today, let's just go odd numbers. Let's go odd. But
I'm reminding you that
I am going to.